Hello, this is a group of BISM 7217, and our topic is about the Google Play. That is how to improve the stores on the Google Play. First, let's introduce ourselves. My name is Carrie. Yeah.
My name is Han Cheng Ye.
My name is Jenny Huang.
And my name is Xin Chen, and now I will introduce my introduction part more specifically.
I will generally introduce Google Play and our research object. First, Google Play is an integrated mobile application market, which provides mobile applications like business, map, education, entertainment, so on and so forth. Also, all apps on the platform are either free or paid and will receive reviews and ratings. In 2018, the revenue of Google Play was $24.8 billion, with almost 105 billion apps installing. In 2017, Google Play overwhelmed Apple Store and became the largest mobile application platform in the world. However, the highest sale does not mean the highest profit. In the third quarter of 2018, Apple Store still earned almost 100% more than Google Play. In this presentation, by using a series of data sets in Google Play, like types, size, prices, we are aiming at finding out the essential factors of how to attract customers and increase app installs, so that the profit of Google Play can be improved.
I will introduce about data description. There are over 10,000 data applications recording this data from Kaggle website, and we choose the attribute as below. Application name, rating from 1 to 5, reviews, size, installs, type which is paid or free, price, content. For example, like everyone can use or adult only over 18. Category, last update, Android version, and we also add a attribute which is demand level. If the installs over 10,000, then the demand level is high, else it's low. About data cleaning, we do data analysis, data standardization, and data normalization. For example, we delete the dollars mark in price and also delete the plus mark in stores to make the string to integer. And we also change the attribute size from KB to MB. And next person will introduce about analysis.
The analysis part. In this part, we are going to talk about two methods. The first method is classification modeling, and the second method is linear regression. Let's go into the first method, classification. Classification as a significant data mining technique can assign different categories to a collection of data, which help to promote the accuracy of prediction in data analysis. And also, classification is an effective method that suits for analyzing large data sets. In our case, the data set we used is very large, with 10,842 pieces of data. Therefore, we are going to adopt a classification as our major method in this research. Another important consideration in this research is the reason why we are going to adopt classification methods in this analysis rather than a clustering method. Clustering and classification are the two types of learning methods with characterize objects into groups by one or more features, but there is an essential difference between the two methods. Clustering is an unsupervised learning method, whereas classification is a supervised learning method. which have a specific purpose and requires data on the target. In our research area, we are going to talk about the Google Play Store and it and we are going to research the relationship between the install amount and the other product features. So we have a specific purpose. We should use the classification as our major modeling method. The major classification methods include decision tree, SVM, logistic regression, naive Bayes, and rules induction. Before modeling, we are going to compare the performance of each method. In order to compare the different methods, RLC curve is necessary to find the optimal model. Let's move into the RLC curve. We can observe the RLC curve includes three curves inside. RLC curve is a curve of probability which uses graphic plots to illustrate the diagnostic ability of a binary classified system. The y-axis represents the true positive rate, while the x-axis represents the false positive rate, which being plotted to create RLC curve. In other words, the curve is more close to the y-axis, the TPI is greater, while the curve is more close to the x-axis, FPI is greater. That means that the left biased curve is more accurate in prediction. Obviously, we can find the decision tree RLC curve is more close to the y-axis. That means the decision tree is the best optimal modeling method for our analysis. Before we model and analysis each attribute, we are going to check the performance for our decision tree model. We choose price, rating, size, and type as the attribute by using select attribute operator and set the demand level as our target dependence variables. The performance of decision tree is working well. We can observe the accuracy of prediction is pretty high. Can reach up to 94.99%. The AUC curve also shows the high success ratio of prediction. In order to analyze the influence factors exactly, each attribute should be researched and modeled separately. The first impact of attribute, we are going to talk about the price. When we observe the decision tree for prices, we can find a clear total change, which is a lower price stimulates more installs and higher demand for the application. This result is reasonable and compensable. At the same time, there are some other interesting results can be found. The applications that price between 12.5 and 13.5 are popular and high demanded. Naive Bayes curve also provides some interesting and useful information. In this figure, the blue curve represents the probability of high demanded prediction, while the red curve represents the low demand prediction. The two curves almost follow standard normal distribution, which means the distribution focuses on zero in price level and the demand of free application is much higher than others. Obviously, the blue curve is concentrated, while the red curve is discrete, which indicates that the prediction about the high demand production is more accurate than it about low demanded productions. The second part, we're going to talk about the decision tree for rating, which can show the impact of rating attributes on installs or demand level. The decision tree of attribute rating exhibits the relationship between the amount of installation and the application rate. The high demanded application distribute in two scales of rating score with 4.1 to 4.75 and 3.25 to 4.146 respectively. In fact, the application with too low or too high rating scores are all not high demanded. So that means if Google Play want to promote the application to stimulate user activation, they should choose some applications that are rated in these two scales. In these two, the application in the price in these two intervals is the optimal strategy to increase the installs and promote the user activation. In naive Bayes analysis, the chart shows the centralized tendency about the prediction accuracy of rating score. The high demanded and the low demanded all follow the normal distribution with centralized in 4.2 around. The two curves are both concentrated. Also, the blue curve is more intensive, which means that the prediction of popularity based on rating is reliable and credible. Another impact of attributes, we are going to talk about the size attribute. After we build the decision tree for size, we can find the decision tree of attribute size is pretty simple and clear, which indicates the relationship between demand level and application size. The demand level of application depends on the different size of an application. When the size of application is over 20.5 MB, most applications are high demand. On the contrary, most applications which is size behind 20.5 MB tend to be low demanded. In fact, this result indeed makes sense because larger size of application usually means high quality and completely functional application. On the other hand, naive Bayes curve about application size are pretty concentrated. The two curves both follow the normal distribution, which means size is significant in this model. And the distribution of low demand application focus on 15 MB around, while the distribution of high demanded applications focus on 27 MB around. That means if Google Play would like to promote some popular application with size around 27 MB is an optimal choice. The last attribute we are going to talk is the type. After we modeling about the decision tree for type, the type of application can be classified by paid and free. The decision tree of attribute type is simple and clear as well. The over half of free applications are high demanded, whereas most paid application is low demanded. If the target of Google Play is stimulating user activation or gain market share, promoting free application could be a great strategy. Also, we should observe the naive Bayes analysis. The distribution of demand level is separated into two groups, paid and free. In the group of paid application, high demanded application more than low demanded application, but not so much. In the group of free application, the low demanded application are much more than high demanded application. The results of classification also prove this impact of price on install of application.
Talk about the linear regression. Linear regression is a quantitative approach to model the relationship between the dependent variable and independent variable by identifying numerical factors. In our case, dependent varieties is installation, and the other independent variables are type, price, size, and rating. Also, the model can help the managers to monitor the features and trends of independent variables in the specific situation. From the result interface, we can find out the coefficient and their accuracy and reliability in the result. Let's look at the attributes of type, rating, size, price. They both have positive correlations with installation, and type is much more influential on the result. Also, we can figure out the linear regression formula. Installation is predicted to increase the first number when type is free, and increase the second number when rating goes up by 1, and the third number is predicted to the installation when size go up by 1. Eventually, the installation will increase the fourth number when price go up by 1. In the performance perspective, from standard coefficient, size is most influential in this perspective, and the p-value of attributes above 0 is that price, which shows that the H0 hypothesis is rejected and the model is reliable. And also, the correlation is 10.2%, which is another view that shows the model is trusted. Next part to elaborate is result of our project.
Talk about the result. According to the ROC curve above, the curve of decision tree is much better than SVM and logistic regression. We use decision tree to predict high demand attribute. As a table, we can see that the high demand attribute of price is 0, rating is from 4 to 4.5, size is from 25 to 30 MB, and type is free. And there are 293 apps consistent to the high demand attribute as above result table. After we analyze the category distribution of these apps, we can find that the top 3 categories are travel, sports, and business. About linear regression, through the formula we can see that type free, rating, and size has positive and significant effect on the amount of app installs. This is the end of the presentation. Thank you for your listening.